So once you do this, then you can see a common, when you look at it from below or above, it is obvious the two vector quantities are all coming to this point. So the resultant vector, which represent the effects of F2 and F1, will be drawing a vector from the tail of F1 to the head of F2. So this becomes the resultant. This becomes the resultant and obeys the triangular law of vector addition. This is F resultant. So from the triangle law of vector addition, we can see that FR is equal to the direction of vector F1 is equal to the direction of vector F1 plus the vector F2. Okay, but as I said, you can only use the triangle law of vector addition, triangle law of vector addition when you have a scaled drawing. So if this is drawn to scale or drawn on graph sheets, then when you measure from this point to this point, it is equal to the addition of F1 and F2. So this is for scaled drawing. If the drawing is not up to scale, or if it is unscaled, then you must use formula. And what is the formula that must be used here? The formula to be used, because we have resolved this into a right angle triangle, then we can use Pythagoras theorem. Okay, so if unscaled, use, and the two forces are perpendicular, use Pythagoras theorem, which is the magnitude of F resultant squared is equal to the magnitude of F1 squared plus the magnitude of F2 squared. So this is the formula to use when two vector quantities are perpendicular to one another. The direction of the resultant, we can determine the direction from east or from north, whichever way you want to look at it. If it's from the east, let's represent the angle the resultant makes with the east using theta. Now, once we have the adjacent to this angle and the opposite, we can use tangent of the angle, tan theta, which is ratio of the opposite side, F1, to the adjacent, which is F2. So that when we find the tan inverse of this ratio, F1 over F2, we can find the direction of the resultant with the east or x-axis. If we want to determine the direction it makes with the north or y-axis, let's represent that by alpha. Because this whole angle is 90, subtract alpha, subtract theta from 90. So 90 minus theta would give you the direction the resultant force makes with the north. That is all. So when two vector quantities are perpendicular to each other, you use the Pythagoras theorem. Okay. Saki, your hand was up. Let me hear from you.
Is okay.
All right. Okay. So last time I gave you an example. Let's quickly, two velocities. Let me redraw it properly. maybe some of us couldn't join on the day. So let me create a question. Two bodies moving with a velocity of, this velocity is due north. And then another velocity is due east. Okay. This question means that the two bodies are moving along two planes, the y and x. So this is 20 meter per second. And then this one is 15 meter per second. The two velocities are perpendicular to one another. This is due east, and then this is due north. Within 2 minutes, please help me find the magnitude and then the direction of the resultant velocity. Let's find the magnitude and then the direction of the resultant velocity. Start with within maximum 2-3 minutes. Please start with. So 2 minutes. We are solving this within, okay, 3 minutes will do. Magnitude. Saki, have you finished?
Yes, sir.
Okay, so keep it. We will discuss it, okay? We will discuss it so you mark yourselves. We are to determine both magnitude and direction. I'm sure the boys among you are watching Champions League.
So it's not only the boys.
The girls as well.
Hey.
So some of them are even doing bets.
This is more important than Champions League. Don't forget. I'm a football fan. And I also play as well. But I mean, important things.
So what team?
Pardon?
What team?
Oh, I used to play actively. Now I just train.
So no, like what team do you support?
Oh, my team is Adam times team. AC Milan. Now we are shadow of our former self. All right, I think your time is up. So let's quickly go through it so you use that to just assess what you've done. Before I can determine the resultants, then I need to realign their directions because this one is due north, and then the other one is due east. So I'm going to realign their directions by creating an equal vectors. So I'm placing this velocity of 20 on the head of the 15 one. So I'm drawing equal vector. The magnitude and directions must be the same. I can also draw Put this one on the head of the 20. So directions. Let me change the color. So this is due north, and this must also be due east. Okay. Once these ones have the same magnitude and direction, this is, hello, Godfred.
Sir, please, why do you have to realign?
So that, okay, so that the two will have a common direction. Because, Godfred, look at, this is due east. This is due north. This is due east. You can't tell where exactly the two are going because they are in their individual directions. So by realigning their directions so that the directions of both vectors will follow that essence of order. The reason why we realign directions. Are you okay?
Yes, sir.
So after realigning their direction, then I can say that, oh, okay, then the shortest possible distance, which will represent this and this, must be drawing a vector from the tail of this to the head of the 20 meter per second one. And you see, I've been able to do this as a result of realigning their directions. Godfred, are you fine? Then I can say that their directions, the resultant will act in this direction because they are coming, this is coming here and this is coming here. So obviously they are all coming to this point. So the resultant must be from the tail of this to the head of this. This becomes F resultant. Now, because the two vectors are perpendicular to one another, then I can use Pythagoras theorem. Saki, quick one.
Then please, so meaning that if there's one force pointing south and another force pointing east, meaning that the angle will be at the top right left part.
Nice question. I'll set another question similar to this so that we look at that. Okay. All right. So the direction of the resultant to the east is here. This is the direction of the resultant to the east. The direction of the resultant to the north is here. Okay. Now, because the two are now perpendicular to one another, I can use Pythagoras theorem. It is not drawn to scale. So F resultant squared is equal to 15 squared plus 20 squared. And what is 15 squared? What is 15 squared?
225.
Plus 400. Let's sum it up. We have
625.
Therefore, when I take square root of both sides, I can find the resultant. What is the square root of 625?
85.
This is 25 meter per second. So this becomes the resultant force, which is the single vector whose effect is equal to the combined effect of this 15 and 20. meter per second vector. Please, are we okay? Then direction. The direction of the resultant. Yes, Godfrey.
Sir, please, what do you mean by scaled drawing?
You see, when you have graph sheets and then you take, let's look at this forces, for instance, or this velocities. Okay, your point is, oh, let every 2 centimeter represent 5 meter per second. So 15, if every 2 centimeter must represent 5 meter per second, okay, it means that for 15, you take 3 of the 2 centimeter boxes. Then for 20 meter per second, you take 4. So when you represent this on a graph sheet, then that is what I'm referring to as a scale drawing. You are drawing it to scale. Okay. For what we are currently solving, we are not representing this on a scale. This is on scale. So when you represent the vectors on a graph sheet, that is a scaled drawing. Godfred, are you fine?
Yes, please.
Okay, Emelda.
So, Sammy, all the questions you've been giving us, we are supposed to use the FR to the power 2 is equal to 15 to the power 2 plus 10 to the power 2 because it's not drawn on a graph.
Exactly. And you can also try it on a graph. Okay, you can try it on a graph, take a shot and send it to me. It must give you the same value. So with concerning the direction, because I know the two forces and then the two forces and then the resultant forms a right angle triangle, I can use tangent to find the direction. When I take the tangent of the angle theta, I have the opposite side, which is 20 meter per second divided by the adjacent, which is 15. And what is 20 divided by 15? 1 point. Oh, area 1.4 divided by 3.
1.33.
1.33 recurring.
3 recurring 3.
Yes, please.
Okay. So determining theta is taking the tan inverse. So on your calculator, you press on shift, then press on tan. Shift.
53.130.
Okay. So this is 53 point. So our angle to the east is approximately 53 degrees. Approximately 53. Now, if I want the direction of the resultant from the north, okay, Godfred. Godfred, I'm listening.
Sir, please, why are we using the inverse?
And whenever you have a ratio and you are looking for the angle, you have to press on shift and then tan. It's not an inverse, but you press on whether sine, cosine, or tan, press on shift, then press on the trig ratio. Okay, that will give you the angle when you have the decimal figure or the ratio. So because you are new to this, that's why you are asking. As you grow, you understand. Okay. So the angle it makes with the north axis or the north, because this whole angle is equal to 90, I must subtract theta from 90. So 90 minus 53 degree will give me the angle it makes with the north. And this must be what?
37.
37.
This must be 37 degrees. So that's how to find the direction in this case. Now let me set another question to answer the question one of you asked. Please, can I forward it? But I'm sure you all got it right.
Yes, we did.
Okay, then then it's a feather in your cap. So another question. Let me even draw XY plane or the cardinal points. In fact, today I'm bent on using different colors. One board. So we have the, this is negative X or west. This is east. We have the north. We have the south. This time we have two forces. One here. This is 100 Newton. Then this is due south. This is also 100 Newton. They all act concurrently. Concurrent forces, meaning they are acting on the body at the same time. So this is the body. So it's like we have a box that is being pushed by two forces. One force pushes a due west. Another force pushes a due south. What will be the direction of the effect of the two forces and then the magnitude? So I can determine their directions by realigning the forces, the direction of the forces, because God said, as it stands, you cannot tell where exactly they are going. So until you realign, you can't tell where exactly the two will be going. Okay, and this can be demonstrated at home when you have any a box. Emelda, push it due west. Let your brother Michael push it due west, south. And you realize that the box will move along the diagonal as you are going to see. So Emelda, experiment for you. So I'm realigning their direction. This, let me also draw an equal vector for this one too. Equal vectors have the same magnitude and direction. So this must have the same direction as this one. Let's call this F1. Let's call this F2. Then this must also have the same direction as F1. After doing this, you can call this also as F1 of magnitude 100 Newton. You can also call this as F2 also of magnitude 100. Now, after doing this, look at their directions now. F1 due west, F2 due south. When you look at it from this direction, F2 due south F1. So obviously, you can tell that they are all coming here. You can tell that they are all coming here, whether you look at it from this side or this side. Please, are we okay? Frank? Frank, I'm listening.
Please, equal vectors also called parallel vectors.
Yes, I said equal vectors are equal in magnitude, equal in direction, and they must be parallel wherever they are. Okay.
Okay, sir.
Saki?
Sir, please, the F1 and F2, do you give it to a specific direction? As in, so if north, if we were using north and east, will you give it to north, or you can just interchange it and give F1 to east?
This is the question must state where F1 is. Okay, I actually set this question up. So I'm giving F1 due west and then F2 due south. So the question actually will determine for you to realign. That's all. Are you okay?
Yes, sir.
Okay, now look at the resultant. It's along the diagonal. Will the direction of the resultant go up or down? Will it go up or down?
Down.
Exactly. Because it will go down because the two, this is going here and this is going here. So you can tell that they are all coming to this point, whether you look at it from below or above here. So the direction of the resultant must act in this direction. F resultant. Okay. Then the next, since the three forces create a kind of right angle triangle, okay, you determine their resultant. You determine their resultant using Pythagoras theorem. And Emelda, this is because this is unscaled. Are you okay?
Yeah, so the lines are representing the graph.
No, this is unscaled. I'm not drawing it on a graph.
Unscaled.
Yeah.
Okay.
Are you okay? So
Yes.
using Pythagoras theorem, I can say that f r squared is equal to, whether I look at it from above, you see we have two right angle triangles, this one and this one. Whichever one you use, the value must be the same. It's still right angle triangle. FR is still the hypotenuse. So F1 squared plus F2 squared. So we have 100 squared plus another 100 squared. This is giving us 100 0 plus another 100 0. In all, we have so that FR is the square root of 20,000. And what's the square root of 20,000?
200.
What's the square root of 20,000? This is 1.414. So 141.4.
141.4.
Yes. That's the resultant. So what we mean by the resultant is that this single vector or force of 141.4, it can give the same effect as 100 and this 100 Newton acting perpendicular to this, to one another in this direction. Okay. Now the direction of the resultant. If I determine this angle it makes with the west, theta, tan of theta is equal to F2 over F1, and that is 1. The ratio is equal to 100 over 100. So theta is equal to tan inverse of 1. And I think tan inverse of 1 is 90. True or false?
False.
Please, 45.
Oh, okay. Thanks for the correction. So 45 degrees. What it means is that the direction makes an angle of 45 degrees from the west. So if somebody is at the west and measures an angle of 45 degrees in an anti-clockwise direction, you determine the direction of the resultant. If you're also standing at the south and you measure 45 degrees in a clockwise direction, you also determine the direction of the resultant. Then we can, you see, conventionally, angular measurement is taken from the north. So I can also follow convention, stand at the north, and then also determine the direction of the resultant. And that is be here and then turn through this angle in a clockwise direction. Okay. Now, if I want to follow convention, then hello, please, if you haven't muted, mute yourself for me. Imelda, mute yourself. If I want to follow convention, then the direction of the resultant will be 180, because from here, from the north to the south, this is 180 degrees. So 180 plus 45 must give me the direction when I pick it from the north. And what is 180 plus 45? This is 225, right?
Yes, please.
So this is 225 north of west. Sorry, south, sorry. North or south. Meaning when I turn through this angle, I can get. So as for directions, usually we want to be, we usually go specific. That determine the direction from the west, from the south. If we don't go specific, then you have to go the bearing way. Okay. If we don't go specific, then go the bearing way, which is this one. Please, are we okay?
Yes, sir.
But if you are picking it from the west, don't forget, if you are at the west, you must turn 45 degrees in an anti-clockwise direction. If you are picking it from the south, you must go clockwise, and you must state that. Okay. Or you can also express that in a bearing form with respect to the quadrant southwest and so on. So that's it. Any question? Any question? All right. Let's then look at when you are given vectors and they are not perpendicular to one another, what happens? Frank, quick one, Frank.
So please, so when you're stating the bearing, the position, do you write, let's say, from where it started from, that's north, then write the degree, the angle, then write the where it ended, that's the south.
Exactly. Exactly. Are you okay?
Yes, sir.
Because for bearings, angular measurement is taken from the north. So if you are not specific, you can go this way and it must be marked for you as well. But sometimes, determine the direction of the resultant from the west or from the south. Then you must go 45 degrees, okay, in an anti-clockwise direction from west or from clockwise direction from south. Okay, so if you have two vectors and they are acting at an acute angle with each other. Example, I have this. I have this axis. Then I have the vertical axis. This is Y. This is X. It can be east, it can be north. Don't forget. Let me check on your. So we have two vectors. This one is here. Gerard, please mute yourself for me. F1 is along the x-axis or due east. This is F2. F2 makes an angle theta. The angle between them is theta. Theta is acute. Why theta? Theta is acute. Anita or Sidel, what is an acute angle?
An angle less than 90.
Anita, come again.
An angle which is less than 90 degrees.
Okay, so I'm coming. Somebody. An angle which is greater than 0 but less than 90. Okay. Class, let me take attendance and then get back to us, okay? So, Anita.
Yes, sir.
Is greater than 0, less than 90. So this is the situation. The angle between F1 and F2 is acute. So when we've dealt with when it is 0, when it is 180, and when it is 90. When it is 0 degree, when the angle between two forces is 0, then it means the two forces are parallel to one another. Take note. When two forces, let me take the attendance and then get back. Okay. When two forces, let me take the attendance and then get back. All right. Hello, are you there? Can you hear me?
Yes, please.
Okay. So when two forces are parallel, it means that the angle between them is 0. When two forces are oppositely to one another, what is the angle between them? When two forces are oppositely. Hello? Frank,
270 degrees.
come again.
270 degrees.
No, Frank. When two forces are oppositely to one another,
180 degrees.
180. So I have a box here. I have a box here. What's a box? And two forces act on them, act on the body or on the box. But the forces are such that they are opposite to one another. So this is here. This is also here, F1, F2. Okay. Yes, they are opposite to one another. And if you want to determine the angle between them, this is the angle, 180. So we've looked at when they are parallel, acting along one direction, when they are opposite to one another, and then we've just seen when they are perpendicular to one another. Then we are reviewing what happens if the angle is less than 90, greater than 0, but less than 90. How we can determine the resultant and then the direction. So this is a typical situation we have at our hands. Okay, so under this situation, how do we find the resultant? Any idea? If you have something to share with us, if you have something like this, how do we determine the resultant? Anybody? Anybody to share something with us before I come in? Okay. Once there is silence, then it means
So please the question again.
we have two vector quantities, F1 and F2. The angle between them is acute. So under this circumstance, how do we determine the resultant? How do we determine the resultant? Okay, Frank.
Please, do you equate the angle to 90 degrees minus theta?
Why 90 degrees minus theta? If 90 degrees minus theta means that you are referring to this angle, this one, the angle F2 mixed with the resultant, with the north. That's what you are referring to.
Okay.
All right, so let me come in. So, as usual, you have to, and Godfred, are you there? Godfred,
Yes, sir.
good. Look at Gideon. Let me come in. Okay, look at the direction of F1. Look at the direction of F2. You can't tell where they are going. Can you, Gideon? Can you tell? You can't figure out where exactly the two forces are going. So we must first realign their directions. We must first realign their directions. so that the directions of the two would follow a certain sense of order. And we can do that using equal vectors. Vectors are equal wherever they are if they have the same magnitude, direction, and are parallel. So I'm going to draw equal vectors of both F1 and F2. Similar to what we were doing when we had that. So F1 will be placed on the head of F2 will be placed on the head of F1. Frank.
So let's form a trapezium, a parallelogram. Sorry.
Exactly. Okay. And one thing you must note, Elikem.
Sir, please, I'm having network issues. Please, can you go over what you just said?
Elikem,
Because I just
we've just started, so you don't worry. Okay.
please not all like when you said you should realign that from that.
Okay. Okay. So Godfrey, mute yourself. So
Yes.
looking at F1 and F2, look at their directions. This is due east. This one makes an angle of theta from east. Okay, you can't tell where exactly the two forces are heading towards. So you must realign their directions so that the directions of both will now follow a sense of order or will make sense. Similar to what we were doing when they were perpendicular. And you can do that using the concept of equal vectors. Vectors are equal wherever they are when they have the same magnitude, direction, and are parallel to one another. And so I'm going to draw equal vector of F2 put on the head of F1. Now this new image of F2 must have the same magnitude as the original. And then, so I'm just estimating the magnitude. So on graph, Imelda, you must measure. Now, because this is the image or equal vector of F2, same magnitude, same direction. This is F2. Note that the angle it makes with the east or x-axis, the same angle must also be achieved here because the two vectors are parallel and are equal. So if this is theta, this must also be theta. In numerical terms, if this is 60, this must also be 60. Then I'm going to also draw the equal vector of F1. Put that on the head of F2. Let me change the color. Today I'm a color man. Okay. It means I must extend the other one a little bit. Good. Same magnitude as this, same direction. So this is due west, east. And so this must also follow. This is equal vectors. Now, when you look at the directions, I can also call this as F1. This is already F1 here. In books, we usually represent the image with broken lines. The reason is to just create the distinction. I don't have that features here. That's why. Okay. Class, are you there?
Yes, sir.
Now looking at the direction. Look at the direction of F1. F1 is going horizontal. F2 follows this way. So this, when you look at it from above, this and then this, there is now orderliness. Godfrey, there is now orderliness in their direction. So you can see clearly that they are all coming to this point, isn't it? Class, isn't
Yes.
it?
Yes, sir.
And so that becomes the resultant vector. The resultant vector is drawing a vector from the tail of this to the head of F2. We have resolved this into the two forces into a parallelogram. Okay. We have resolved it, the two forces into a parallelogram of forces or vectors. Frank, I think I answered your question. You said, yes, two vectors are parallel when the two forces, yeah, the angle between them is 0. If they are opposing forces, then they are in opposite direction. Parallel, they must act along the same direction, and the angle is 0. If they are opposing, the angle is 180. Okay.
Yes, sir.
Okay, so we have resolved them into parallelogram of forces. Now, after resolving this shape into a parallelogram, please don't forget that with a parallelogram, interior opposite angles are equal. So this angle here must be equal to the angle here, and the whole angle here must also be equal to what is here. All right. Now, you could also realize that this obeys the triangular law of vectors after realigning their directions. They are all coming here. So we can also apply the triangle law of vector addition here. That's FR is equal to F1 plus F2. But Imelda, as usual, you can use this to find the resultant only when the two it is a scaled drawing. Imelda, are you there?
Yes, please.
So only when it is a scaled drawing. So if it's a scaled drawing, when you measure from the origin, from this point, the starting point to this point, what you have will be the same as measuring from here to here plus from here to here. But if it's not a scale drawing, then you must use a formula. And what is this formula? This formula is known as cosine rule. So if it's on scale, you have to use cosine rule. Cosine rule. Rule to find the resultant. Now I'm going to derive the cosine rule with you. I'm not going to just write it for you, but derive it with you so that you see how it was obtained. We can derive the cosine rule using even Pythagoras theorem. Using Pythagoras theorem. Let me draw a perpendicular line from the resultant to this point. So that the two are perpendicular. As for this one, fasten your seatbelt because you haven't done much of trigonometry. So I'm going to apply things you haven't learned. So yes. So fasten your seatbelt, open your eyes and your ears, ask questions if there is a need, okay? Now, after drawing this line, since this is perpendicular to the east axis, you can draw a perpendicular line to indicate that the angle here is 90. Let's label this point as O. O, this point as A, and this point as B. Looking at triangle OAB. Godfred, what kind of triangle is this? What kind of triangle have we achieved here? OAB. Godfred. Okay,
Right
Frank.
angle triangle.
Okay, the right angle triangle. Good. So we can deduce that the square of OA squared is equal to AB squared plus OB squared, isn't it? Godfrey,
Please explain it again.
please mute yourself after coming in. So, Godfrey, mute yourself. We have right angle triangle OAB, isn't it? And so we
Yes,
can
sir.
apply Pythagoras theorem to this right angle triangle. That triangle OA squared, the side OA squared plus is equal to the square of AB plus the square of OB. And that's what I've done here. Now, please watch watch closely. I'm extracting. Okay, let me also label this part, this particular point, and call it C. I want to extract a smaller right angle triangle from the bigger one. And that is AB, then C. I mean, just this small part with the angle theta there. Okay. This is F2. This is F2. Gerard, please mute yourself for me. Now, this side is still perpendicular to AB, is still perpendicular to CB as well. Now, this is the hypotenuse. CA, which is represented by the force F2, is the hypotenuse. AB is the opposite to the angle theta. CB is the adjacent. They also follow the triangle law of vector addition. Now, if I have the angle and I have the hypotenuse and I want to determine the opposites, this opposite and the adjacent, how do I do it? If I want to, once I have the hypotenuse and then the angle, if I want the opposite, if I take sine of the angle theta, sine theta, I have the opposite, which is unknown, divided by the hypotenuse, which is F2. When I make the opposite, which is unknown, the subject, I need to multiply through by F2 to eliminate it. So times F2. This cancels out, and I'll have the opposite, which is unknown, to be F2 times sine theta. So meaning for this force and the angle, the vertical component is F2 sine theta. Class, are you okay with this? Are you okay? Then the horizontal component, which is the adjacent. If I'm looking for adjacent, which is this part, which is also unknown, the adjacent can be obtained using cosine. So if I take cos of the angle theta, cos theta, I have the adjacent, which is unknown, divided by the hypotenuse F2. The unknown adjacent will be equal to F2 cos theta. So it means that this part CB is also F2 cos theta. Class, are we okay here?
Sir, please, no, please,
Sir.
let's go by again.
Hello?
Sir,
Ask questions.
sir, please, are you finding the magnitude of the angles?
No, you see, I took out triangle ABC out of the bigger triangle OAB. The reason is that, you see, we have this part OC. We have the part CA or AC, but we don't know AB and we don't know BC or CB. So we are looking for those parts so that we can add that to F2, F1 in order to obtain OB. You see, OB is equal to OC plus CB. OC is known. OC is equal to F1. CB, you don't know. You don't know CB. So I'm looking for CB so that when we add that to F1, we can find OB. Please, is that understood?
Yes, please.
We don't know AB either. So we are using this force F2 tilting to an angle theta to find AB. So we are basically looking for the unknown part so as to enable us find OA, which is the resultant force. That is why. Saki.
Please, I still don't get it.
Which part? Saki, which part?
That is when Imelda asks if you are finding for the magnitude of it, that explanation, you get it.
The whole point is that we are looking for the magnitude OA. Let me clear some parts. Once we found those parts, let me clear it, and then I understand your confusion because you are new to these things. But as we move on, you'll be used to. So you don't worry. Okay, so all that we are doing is that we are actually looking for the resultant OA. But as I said, considering triangle, the bigger triangle OAB, we can see that OA, since it forms a right angle triangle, OA squared will be equal to AB squared plus OB squared. So when we manage to find AB squared and then find OB, we are good to go in finding OA. Now what is OB? OB is equal to OC plus CB. We know OC. OC is F1. We don't know CB. That's why we are using F2 and the angle it makes with the east to find CB. Emelda and the rest, are you okay? Saki.
Yes,
So we are just basically looking for CB, but we could find CB using F2 and the angle it makes with the east. We can also use the same F2 and the angle to find AB. That is the reason why we picked out triangle ACB to find for its opposites and then the adjacent. Knowing that this is perpendicular theta, this is F2. The vertical side or the opposite becomes F2 sine theta. The horizontal side, which is the adjacent, becomes F2 cos theta. So we've used F2 and the angle to find the various parts. Having had this, Frank.
sir. So the sine and the cos, did you use because of the trigonometry?
Come again.
Like the sine, did you use because you're finding the opposite and the
Adjacent.
cos. Yes, you're using and the adjacent.
We are using the sine and cos because we are looking for opposites and the adjacent. We have the angle, we have the hypotenuse. Don't forget, we cannot use, once you have the hypotenuse, you cannot use tan because tangent does not involve hypotenuse. Are you okay?
Yes, sir.
Okay, so it means that OB is now F1 plus CB, which is F2 cos theta. Okay, so let's substitute whatever we've had for our values in OA, which is the resultant F resultant squared is equal to AB. AB is F2 sine theta. Sine theta all squared. Put everything into bracket plus OB. OB is now F1 plus F2 cos theta all squared. Class, I want you to expand OB for me. OB, which is F1 plus F2 times cos theta all squared. Expand this for me. I mean this one within a bracket. Of course, this will be F2 squared times sine theta squared. or sine squared theta? You have to work this out for me. Please,
Will it be f1 squared plus f2 squared cos squared theta?
come again.
F1 squared plus
Let
f2.
me give you a trick. Use a plus bx all squared. Expand a plus bx all squared. Hello, Frank. What's your answer?
F1 squared plus f2 squared cos theta squared.
No, you have left something out. So first, expand a plus bx all squared, and we'll give you the picture. Exactly.
Step this f1 squared plus f2 squared plus which is also multiplied by cos theta squared.
Okay, you keep on trying. After everything, I'll do it with you. Another hand is up. Please go ahead. Sidel, go ahead.
So please, it will be f1 squared plus f1 times f2 cos theta plus f2 cos theta squared.
Okay. Okay. All right. All right. So let's deal with it together. Let me clean this part and use the other space. Usually, the best thing is, in order to save time, the best thing is to write the formula for you, but I'm not fond of doing that. So let's go through it. And when you understand, that will be easier. Okay, so let's do it. So your task is to expand F1 plus F2 cos theta all squared. Please don't forget, this is the same as F1 plus F2 cos theta times another F1 plus F2 cos theta. Okay, so you can expand it this way. F1 times F1 is F1 squared. F1 times F2 cos theta is F1 F2 cos theta plus F2 cos theta times F1, another F1 times F2 cos theta, then F2 cos theta times F2 cos theta. You have F2 cos theta all squared. And this, when you rearrange this, you have F1 squared. This is plus 2F1 F2 cos theta. 2F1 F2 cos theta plus F2 squared cos theta squared. But cos theta squared is also written as cos squared theta. So this will be the expansion. Saki. Saki, your hand is up. Go ahead. Oh, Saki. And Ida. Hello, can you hear me? Class, can you hear me?
Yes,
Yes,
please.
sir.
All right. So this is the expansion. So let's bring them together. FR squared. Don't frighten up. We are just deriving a formula to use. F1 squared is equal to, when we expanded F2 sine theta squared, we had F2 squared sine squared theta. Then the expansion of what I gave you, let's add it, F1 squared plus 2F1 F2 cos theta plus F2 squared cos squared theta. Let's now group like terms. Let's group like terms. So F1 squared plus F2 squared. Then let's put sine squared theta. Oh, sorry, there's
There's F2 in front of the sine squared.
yes. We have F1 squared plus, hold on, let me clear this part and correct. Okay. Open your eyes. So we are just deriving a formula which we'll use later. So F2 squared sine squared theta plus F2 squared cos squared theta. And finally plus 2F1 F2 cos theta. F1 squared, let's factorize out F2 squared. F2 squared out into bracket sine squared theta
Theta plus cos
plus
squared
cos squared theta plus 2F1 F2 cos theta. Now, in trigonometry, sine squared theta plus cos squared theta, this summation is equal to 1. Remind me tomorrow during our meeting to prove this for you. Why sine squared theta plus cos squared theta is equal to 1. Today, I wouldn't prove it because we've done so much. Let me spare you of proving today. So remind me tomorrow to do this for you. So because the square of this plus the square of this is equal to 1, when we put everything within the equation, we have F1 squared plus F2 squared. What is inside the bracket here is equal to 1 plus 2F1 F2 cos theta. If we are looking for the resultant. FR is equal to the square root of all these. F1 squared plus F2 squared plus 2F1 F2 times cos of theta. Ladies and gentlemen, this is what we call as the cosine rule. The cosine rule. This is the cosine rule. Okay. So when you resolve the forces into a parallelogram and they obey the triangle law of forces, because it's not a scaled drawing, you use the cosine rule to find the resultant force. How do we determine the direction? We can determine the direction using the same thing. You see, concerning the direction, we are looking for there's the resultant. The direction it makes, the angle it makes with the east, which is this angle. Let's call this angle alpha. Class, alpha and theta, which one is larger? Alpha and theta, which one is larger?
Please come again.
Looking at the diagram, let me read your message and I'm coming. I want to read your messages and get back to you. Yes, Frank, are you signed? I think I explained that. Yes. Okay. Okay. So, Quentin, why are you gone?
Please, I'm still here.
Oh, okay. Then you can quickly do that. Okay.
Okay, sir, thank you.
All right. So, Saki.
Yeah, please, theta.
So, looking at theta and alpha, theta is bigger than alpha. Theta is the angle between the forces, the two forces given to you. Okay. So, alpha is the angle the resultant makes with the east axis or with the x-axis. So, the direction of the resultant is actually this angle. Then we can also determine the angle from the y or from the north, which is this. So let's first find this angle it makes with the x. And since we resolve the forces into a right angle triangle, we can also use tangents. The direction, if we take tan of the angle alpha, tan alpha is the opposite, which is F2 sine theta, F2 sine theta divided by the adjacent, which is OB. Let me use the letters in order to give a systematic understanding to what. So if we take tan theta, okay, alpha, AB is the opposite. So AB divided by the adjacent, which is OB. let's substitute whatever we have for it. AB is F2 sine theta. Then OB is F1 plus F1 plus F2 cos theta. So when you take this ratio and take the tan inverse, you have the angle alpha. Frank,
So is it possible to instead write OC plus CB instead of the OB?
is it possible to still write what?
Like instead of AB over OB, it would be AB over OC plus CB.
Oh, you can, yes. Because OB is OC plus CB, yes. Hello, Saki.
Sir, please, why is it AB over OB and not AB over OC? Sorry, BC.
You see, we are using the bigger triangle because this is about the resultant. The resultant OA. So use the bigger right angle triangle. Are you okay? So
Yes, sir.
we are using triangle OAB. So if you are looking for this angle, then is the opposite, which is AB over the adjacent, which is OB. Frank, are you okay?
Yes, sir.
I want us to use this in trying a question before we close. Understanding this and applying it to solving questions, okay, will bring clarity than just deriving the forces or the formula. There is also another formula for determining the direction, but as we move on, I'll introduce you to it. So let's give ourselves a very nice question to quickly try in order to deepen our understanding before time is actually up. The Madrid faithfuls, what's the score line? I know as you sit, you are still watching something.
0-0.
Hey, as we don't pay young one now. Do we have some Arsenal fans in the building?
Yes, sir.
Okay.
Yes, sir.
All right. Anyway, I think because of Thomas Partey, we are all Arsenal faithful by default. All right, so let's try solving a problem. Two forces of magnitude Anita, are you there?
Yes, sir.
Okay. Then another force so the angle between them is this is 45. So theta is 45. F1, this is 20 Newton. F2, this is 25 Newton. The angle between them is 45. We are to find the magnitude of the resultant and the direction. Okay. So how do we determine this? Yes, you can use the formula, but in order to deepen our understanding, I would use the various approaches used. So let's realign their direction. Godfred, are you there?
Yes, sir.
For realignment of direction, I'll always call you. And for scale drawing, I'll always call Imelda. So this is Godfred, mute yourself. So direction equal vectors. So obviously the resultant would act along the diagonal. So before you use a formula, you must let it obey the triangle law of vectors. So this is F resultant. Saki, your hand is up again. What's your secret?
Sir, please. So, is there a law if the diagram doesn't or the question doesn't obey the triangular law of vectors?
And then you can't use it. You can't. No, there's no law. But you must realign their direction so that it obeys the triangle law of vector. That is when you can either use the formula or if it's a graph, use a scale. If it doesn't, whatever you have as your answer will be wrong. Emelda, you don't like us now. Whom do you support? Brekum Chelsea. Okay. So once I've done this, then I can say that this is also F1. This is 20. Okay. This is, and once this is F1, this is also F1. When I extend this line, it must also make the same angle. It must make the same angle. This is also an angle of 45 because they are equal. Once I've done that, I can draw a perpendicular line from here in order to determine the unknown. And this must be perpendicular to this. The unknown, they must also obey the triangle law of vector. So this will go up so that the resultant is here. As we resolve this, will be equal to F1 times sine theta. So F1, which is 20 times sine of 45 degrees. This side must also be equal to the same 20 times cos of 45 degrees. The theory is what we were doing here. F2 sine theta, F2 cos theta. So that's what I've done here. What is 20 times sine 45? I think sine 45 is root 2 on 2. So 10 root 2, which is 14 points.
14.14.
Okay, 0.14. 20 cos, this is the same results. 14.14. Right?
Yes, sir.
Yeah.
Good. So if I want to determine the resultant, F, the square of the resultant, is equal to the direction, I don't know, alpha. Opposite, the opposite is the square of the opposite, so 14.14 squared plus the adjacent. Okay, the adjacent is, this is 25 plus 14.14. The square. I have rank.
Sir, are we finding the resultant of the smaller triangle or the
No,
bigger one?
the bigger O A B. So this squared is equal to the opposite squared, AB squared plus OB squared. So that's what I'm doing. And AB squared is 14.14, isn't it?
Yes, sir.
Exactly. So what is 14.14 squared? Let's hurry up.
199.93.
199. So let's take that to be approximately 200. Okay.
Yes, sir.
Sum up what is in the bracket and then square it for me. 25 plus 14.14.
The 1,500.
Come again.
1,000.
1,532.
1,532.
31.
Okay. All right. So add that to 200 for me.
$1,732.
1,700 okay, so
31.
yeah, FR is the square root of that. What's the square root of that? Square root of 1,731. Hey, where am I?
40,
Pardon?
41.6.
This is 41.6 Newton. Let's use the cosine rule. We had FR equal to the square root of F1 squared plus F2 squared plus 2F1, F2, cos of theta. Do that and see for yourself. So F1 is 20. F2 is 25. Two times 20 times 25 cos of 45. Do that and then give me the feedback. Are we true?
41.6.
So theory no lie. The same as what we had. So you can resolve it into a parallelogram and later apply Pythagoras theorem or use the formula straight away. Let's look at the angle. Tan of alpha. Tan of alpha. Opposite, which is 14.14 divided by the adjacent, which is 25 plus 14.14. Let's sum what is 25 plus that? 39.14, right?
Yes.
Take the ratio and then divide it. Anna. Oh, Anna didn't show up today. Today, are you gone? You are watching Real Madrid. So this ratio is 0.361267. Therefore, when you take the tan inverse of this, tan inverse of 0.36127, theta will be equal to, yes, what's the tan inverse of that?
19.863.
19.863. So approximately 20 degrees. That is the direction of the resultant force. 2 due east. Now, if I want the direction of the resultant force to the north, yes, there's a direction which is approximately 20. Okay, and this whole angle is actually 90. So from the north axis, if I subtract 20 from 90,
70 degrees.
which is 70, the angle the resultant makes from the north is 70. So 70 degrees north of, okay, east. So that's the direction thing. Okay. So this is when the angle is acute. I'll introduce you to when the angle is obtuse, how to go about it. And we have another method of determining the direction, which is known as the sine rule. I'll introduce you to sine rule, and from there we'll solve questions as usual. Class, is that okay? So if there is any question, please quickly ask. Is there any question? Saki.
Sir, please, how did you get the 70?
Subtract 20 from 90. Because the whole northeast quadrant totals 90. So if a section of it is 20, then the remaining angle is 70. Are you okay?
Yes, please.
Is there any more question, class? Let me check your messages. Emelda is telling somebody to concentrate. Okay. It's good. Let me see those of you who were able to survive. So Ida, do you have any question?
No, please.
There are some names that are very familiar to me because do you know I used to be at Gehe? Yes. And I had Ada in my class. Okay. So, in fact, since we have another class tomorrow, if you don't have any question, this is where I draw the curtains on our meeting. We'll continue once more tomorrow. Okay. Have a very good night, and please revise. Okay, Augustine, tomorrow we'll be trying solving questions, so you don't worry, okay? Gideon,
Okay.
Sir, please, can I send today's video to the group?
I will. That's the reason for which it's being recorded. Okay. All right. So good night to all of you. We'll try solving questions tomorrow. Bye-bye.
Good night, sir. Bye.
Bye-bye.